Alright guys, here's your study video for the rationals functions unit. The first half is we are going to simplify. We're going to do operations, so multiply, divide, add, subtract, and then towards the end we're going to do word problems and we're going to actually solve rational functions. So first off we have multiplying. Alright, so looking across here I have monomials everywhere. There's a couple of things you could do. You could simplify first or you could do it last. I like to just go ahead and multiply straight across and then cancel out in the end. But if you do it the other way, you should get the same answer. So my numerator, I have 3 times 5, which gives me 15, and then n. Our denominator gives me 42 n. Obviously, my n's are going to cancel out. My 15 and my 42, though, they're both divisible by 3. So if I divide each of these by 3, 15 divided by 3 is 5. 42 divided by 3 is going to give me 14. So my ends are canceled. My final answer is just going to be 5 over 14. All right. Number 2 has a little bit more stuff going on. We already have it in factored form. So remember, when we have a constant here, technically it means it's over 1. So I can cancel common factors as long as it matches in the numerator and the denominator. So here, m plus 5 and m plus 5 can cancel. Same over here, m minus 3 and m minus 3. So I'm left with an 8 times 9 on the top, which is 72, and then just a 1. So 72 is our answer. All right, number 3, I'm going to have to do some factoring first. Especially this numerator right here. So I notice that 3 and 15 are both divisible by 3. And I can also take an x squared out of each of those. So that's the same thing as saying 3x squared times x plus 5. All right, now I can start canceling things out. X plus 5 and the 3x squared. So all I have left is just the 7, so the answer here is just 7. These are nice. All right, number 4. I see some factoring going on. This denominator, I can take a 2 out. I'm left with just an x minus 1. This numerator, I can actually take a 2 out of this, and it becomes 7x plus 2. All right, let's start canceling things. I see 7x squared, 7x plus 2, 7x plus 2, and then a 2 and a 2. So it looks like my numerator is going to have 8x squared, and my denominator will only have x minus 1. All right, I cannot cancel these out because this x is being attached with the minus sign. So I cannot do anything. We are done. All right, last multiplying problem, number 5. I need to factor, I can actually factor every single piece. So this first numerator multiplies to give me 12, adds to give me negative 7, is going to be negative 3 and negative 4. Down here, multiplies to give me negative 8, but adds to give me negative 2, is going to be negative 4 and positive 2. This numerator, it's not a trinomial, it's just 2 pieces, it's a binomial. So I can take something out of each one, which is a 2. Left with r plus 2 on the inside. And then our denominator here multiplies to give me 24, adds to give me negative 11. That's going to be an 8 and a 3, and negative 8, and a negative 3. All right, lots of factoring going on, so now I can ignore these pieces. And I can start canceling out common terms. All right, I see r minus 4. I see r minus 3. I also see r plus 2. So the only thing I have left in my numerator is the 2. And the only thing we have left in our denominator is r minus 8. All right. Now we're going to move on to our division section. We're going to start it off. I'm going to ask you to find the excluded values. Okay, so remember, excluded value is something that's going to make your denominator equal to 0. So when we're looking at a division problem, it's sneaky because both of these pieces are going to eventually be in my denominator, right? If I were to actually solve this, my very first step would be to flip the second fraction. You would multiply and then flip. See that? So, denominator, denominator, and also this denominator. Let's factor this one. Multiplies to give me 24, adds to give me 14. It's going to be a 12 and a 2. So x minus 12, x minus 2. This one is going to give me x plus 8 and x plus 3. So what would make this piece 0? Well, that would be if x was 12. So x cannot equal 12. Right here, x cannot equal 2. That would make that piece 0. Here, I can't have negative 8. Here, I can't have negative 3. And remember, this one started off in my denominator. I have to look at that also. This will give me x equals 2 as an excluded value, which we actually already have listed. So these are our excluded values for number 6. All right, number 7, we're actually going to start simplifying. Remember, all of the division problems, your very first step is going to be to flip the second fraction. All right, don't do anything else. So I'm going to have 12 over 5x times 15 over 6. Flip it first. All right. Again, you can start simplifying here, or you can wait towards the end. Last time I went straight across. This time I'll do it the other way. So I see 12 and 6. I know that's 2 and 1. And I see 15 and 5. I know that's 3 and 1. So up top I have 2 times 3, which is 6. I have 1 times x times 1, which is just x. So that is our answer for number 7. All right, number 8. Again, first thing I'm going to do is to flip our second rational function. So we're going to make it x plus 4 over 1. Now I'm going to factor anything that I can. I can factor this one. So what are two things that multiply to give me negative 8 but add to give me a positive 2? Is going to be positive 4 and negative 2. Alright, just like last time, I can cancel things out. So my numerator, I have x minus 5 still here. In our denominator, we have x minus 2 and 1. So we're just going to have x minus 2. That's our answer for 8. Alright. Moving on to number 9. Let's flip. So we have x plus 7 over x plus 2 multiplied by x squared minus 3x minus 10 over x squared minus 49. All right, these I cannot factor, but I can actually factor both of these guys. What multiplies to give us negative 10 and adds to give us negative 3? That's going to be a 5 and a 2. We're going to need a negative 5 and a positive 2. And then our denominator is actually a difference of squares. So this factors to be x plus 7 and x minus 7. All right, common factors are x plus 2 and x plus 7. So our numerator, we have x minus 5 left in there, and our denominator still has the x minus 7. That's our answer. All right, last of our division problems. This one has a whole lot of factoring going on. Okay, but before I think about factoring at all, I need to flip it. Okay, so we need to keep this fraction, change to multiplication, and then flip. I think you've heard of keep, change, flip before. So keep this the same. X squared minus 4x minus 21 over x squared minus 14x plus 24 multiplied by, flip these two, x squared plus 6x minus 16 over x squared plus 11x plus 24. All right, now let's do all that factoring. Over here, multiply to give me negative 21. Add to give me negative 4. A 7 and a 3. Let's see, negative 7, positive 3. Down here, we are going to need two numbers to multiply to give me positive 24. Add to give me negative 14. That will be negative 12 and negative 2. So we're done with those. Here multiplies to give me negative 16, but adds to give me a positive 6. That will give me positive 8 minus 2. And then this denominator, we will have two numbers to multiply to give me 24, add to give me 11. That is a positive 8 and a positive 3. Okay, now let's start canceling. X plus 8, x plus 3, what else? X minus 2. Okay, I think that is it. So numerator will just have x minus 7, and our denominator will have x minus 12. All right, good job. All right, time to add. All right, so remember, with adding and subtracting, your first goal is to get a common denominator, okay? Because you cannot add and subtract fractions, which is what rational functions are, without having a common denominator. Number 11 here already has a common denominator, so I don't have to do that step. What I can jump to is combining like terms up here. So we're going to have x plus 3 plus x minus 8. Combine like terms. X plus x gives me 2x. 3 minus 8 gives me negative 5. And let's put it all over our common denominator, which is x squared minus 5. All right, we like it when our denominators are the same. Like 12 over here. Again, same denominators, so we know it's going to be 15x. Combine like terms, 3 plus 7 is 10. Okay. We can do some simplifying with this one. See my x's? So my x's will cancel away. Also, 10 over 15, if I divide them both by 5, it's the same thing as saying 2 over 3. So that one simplifies to just 2/3. All right, number 13, again, same denominator. So we know we're going to have 30x in the bottom. My numerator is going to be 8x plus 6x, so 8 plus 6 is 14x. Just like last time, x's cancel out. 14 and 30 are both even numbers, so I can divide them by 2. So that's going to give me 7 over 15. Simple enough. All right, now it's going to not have the same denominators. Okay, so I need to make them the same. All right, right now these two look totally different, but I can factor this one, so I'm going to. This factors to be x plus 7 and x minus 8. Okay, now I can see that both sides share the x plus 7. This side, though, is missing the x minus 8. So I need to multiply it in the denominator. And since it's a fraction, if I do it to one piece, I have to do it to the other piece. Right? Denominators are now the same, right? That like denominator is going to be x plus 7, x minus 8. My numerator now, though, is going to be 3x minus 2. And then plus 9x minus 72 as my numerator. Last thing we're going to do is combine like terms. I have 3 plus 9, which is going to be 12x. And then I have negative 2 minus 72, which is minus 74. All over x plus 7 and x minus 8. Let's see here. I bet you this can simplify some more. It is 74 divided by 12 is not a thing. Okay, but they're both even, right? 12 divided by 2 is 6. 74 divided by 2 is 37. So I could factor this one more time. Doing this assures me that there's nothing else I can cancel. Okay, if I did this step and I was able to cancel something out, then I would. But I see that I don't have any common factors, so that's my final answer. All right. One more. Again, denominator is not the same, but I'm able to factor this one, so I'm going to. So this factors to give me x plus 17 and x plus 2. So I see that both of my denominators share the x plus 17. I just need to add x plus 2 over here, which means I must also multiply it to the top. Doing that means I'm going to end up foiling these two. Okay, so my numerator, I'm going to have 5x plus 2 from over here. Now we're going to FOIL. 2x times x is 2x squared. 4x, right? 4x minus 3x is positive x. And then negative 3 times 2 is negative 6. All over x plus 17 and x plus 2. All right, now let's combine like terms. All right, I see 2x squared. And then I have 5 plus x, that gives me 6. And then I have 2 minus 6, which is going to be negative 4. All right, and I can actually keep going with my numerator because look, 2, 6, and 4 are all even numbers. I can take a 2 out of there. So it's going to be 2 times x squared plus 3x minus 2 all over x plus 17, x plus 2, and then, yeah, I can keep going. This factors, look, negative 2 times, nope, maybe not. Nope, we're done. This does not factor anymore. If it could factor, though, then I would have and hopefully be able to cancel stuff out. But I can't. So problem is done. Because nothing multiplies to give me negative 2. The adds give me a positive 3. If that would have been negative, then I could have kept going. But it's not. So we're done. All right. Subtracting. It has the same idea as adding. Only difference this time is we're going to have to distribute that negative sign to everything next to it before I do anything else. So here I need to make this negative x and negative y. Now I notice that my denominators are the same, so I can actually just combine like terms across the top. I see 6 minus x minus y. Those are not like terms, so we're just going to keep them all separate like that. 6 minus x minus y all over 10y squared. Nothing else I can do. That is it. All right. I'm actually going to skip 17 right now. I'm going to go to 18 because I see 18 has common denominators. Remember, apply my negative to both pieces. So this is going to be a negative x and a positive 4 when I do that. Now I can combine like terms across the top. X plus negative x, that's going to cancel, right? If I write this out, look, x minus x, they go away. And then 2 plus 4 gives me 6 over 5x and 2x minus 5. And that's it. Nothing else to do. Okay, 17. Let's go back to that one because denominators are not the same. But before I even touch it, apply my negative. So my negative comes up here with the 6x. They both have a 6, but this side has x squared and y. This side needs x squared and y. So if I do it to the bottom, I must do it to the top. Right? So now we're going to multiply that through. So we're going to have 4x squared y minus 6x all over 6x squared y. And the only thing I can think of to make this simpler is factor out a 2 from the 4, 6, and 6. But nothing else is going to change. I cannot cancel these out because my numerator is attached to something else by the subtraction sign. So it's locked in. But my constants right here, or my coefficients, I'm sorry, they're all even numbers. So I can divide each of those by 2 to give me 2x squared y minus 3x over 3x squared y. That is all we can do. All right. Let's go to 19. All right, first things first, distribute that negative. Now I see that I have two denominators that are have nothing in common. So in order to make them the same, I'm actually going to multiply each side by the other denominator. So see how now they're both x minus 5 and x minus 4? That's what I need. So since I did that to the denominators, I have to also do it to the numerators. All right. Let's simplify. So we have 6x minus 30. And then over here I have minus 5x plus 20 all over x minus 5 and x minus 4. Combine like terms. 6 minus 5 gives me a positive 1. Negative 30 plus 20 is still negative 10. All over x minus 5 and x minus 4. And there's nothing else I can simplify. All right, last subtraction problem, number 20. I'm going to work out 20 the same way that I just did 19 because there's no way I can make my denominators match. All right, distribute my negative to the 3. There we go. Now I need to multiply this side by 5x plus 2. And we're going to multiply this side by x minus 3. Okay, denominators are the same. So now I can worry about just my numerator. On this side, we're going to distribute that 2. This will become 2x minus 6. My other side will become negative 15x and then minus 6 all over x minus 3 and 5x plus 2. Let's combine like terms up here. 2 minus 15 is going to give me negative 13. And then negative 6 minus 6 gives me negative 12. All over our common denominator of x minus 3 and 5x plus 2. All right, so that's all of our operations. So we had multiply, divide on the front, add and subtract on the back. Now we're going to get to word problems and solving. So I'm actually going to do word problems first. We have 5 of them. Number 21. Let me zoom out a little bit so we can read it. Lawson can paint a certain fence in 3 hours by himself. If Lucas helps, the job takes only 2 hours. How long would it take Lucas to paint the fence by himself? Okay, so remember how we set these up. We look at the job and the time it takes to do that one job. Okay, we do each individual. So here we have Lawson and Lucas. So Lawson by himself does the one job in 3 hours. So his ratio is 1 job in 3 hours. Right? Lucas, if he helps him, it only takes 2 hours. That means when they do it together. So we know it's going to equal 1 over 2. We do not know how long it's going to take for Lucas to do it by himself. So we have Lawson by himself, Lucas by himself, equals what they do when they're together. Okay? So in order to solve for x right here, I need to multiply each one of these by our denominators, which are 3, x, and 2. So they each get 3, x, and 2. And the reason for doing this is so we can cancel out the common denominator and get rid of our fraction. So look here, the 3's cancel, in the middle the x's, and on the end it's the 2. So I end up with 2x plus 3 times 2, which is 6, equals 3x. All right, so now we're going to solve for x. All I have to do actually is just subtract 2 over, and I get 6 equals x. So what does that mean, 6 equals x? Well, it means that Lucas would take 6 hours to paint the fence. All right, so if he did it alone, it would take him 6 hours. All right. 22. Every week, Natalie must stuff 1,000 envelopes. She can do the job by herself in 6 hours. If Jessica helps, then they can get the job done in 5.5 hours. How long would it take Jessica if she did the job by herself? Okay, so again, I have an individual and I have a together time. This 1,000 does not matter. It's not going to do anything. All this is showing is that they are both doing the same job. So to set it up, I have Natalie first. So Natalie does it in 6 hours. So we have 1 over 6 plus, I don't know Jessica yet, that's what it's asking me. So 1 over x equals their together time of 5.5 hours. So we're going to multiply each piece by each denominator. So they're all going to get multiplied by 6x and 5.5. 6x 5.5 and 6x 5.5. All right, let's cancel out some common denominators. Here we go. We have 6 and 6. Here we have x and x, and on the end we have 5.5 and 5.5. So this is going to give me the equation of 5.5x plus 6 times 5.5, which is going to be, let's see here, 33. So 6 times 5.5 is equal to 6x. All right, let's get x by itself. Let's subtract that over. So 33 is going to equal 0.5x. All right, and then we're going to actually divide 33 by 0.5. And we get 66. Oh my goodness. Okay, so Jessica, I'm going to need you to work on this, honey. If Jessica stuffed the envelopes by herself, it would take 66 hours. Jessica does not need to do this job. Jessica would take 66 hours. That's crazy. Ah. All right. Moving on. 23. We have Mr. Clark has discovered that a large dog can destroy his entire garden in 2 hours, and that a small boy can do that same job in 1 hour. How long would it take the large dog and the small boy working together to destroy Mr. Clark's garden? All right, so let's see how fast the destruction can take place. So I actually know the two individuals this time. I know the dog can do that job in 2 hours. The small boy can do it in just 1 hour. So I want to know how long will it take them to do it if they are in cahoots with each other. All right, multiply by 2, 1, and x. So all of them, 2, 1, and x. Over here, 2, 1, and x. All right. 2's cancel. 1's, x's. So we are left with just x plus 2 times x set equal to 2 times 1, which is just 2. Add those together. We have 3x equals 2. Divide, x equals 2/3, or about 0.66. Right? So if the small boy and the dog destroyed the garden together, it would take 0.66 hours. So they would get it done in less than an hour if they worked together. All right, let's go on to 24. With only a small valve open, all of the liquid can be drained from a large vat in 4 hours. With only the large valve open, all of the liquid can be drained from the same vat in 2 hours. How long would it take to drain the vat with both valves open? Okay, so we have 2 valves doing the same job. If my small valve is open, it's going to take it 4 hours. So they're going to drain it in 4 hours. That's the one job, is to drain, right? The other one is going to take 2 hours. So that same job was only going to take 2 hours. How long is it going to take if they work together? So remember, we're assuming it's going to be about half, right? You should cut their work in half. So we're thinking between 1 and 2. Okay, let's see if it works. Multiply by 4, 2, and x to all sides. 4, 2, and x. 4, 2, x. And over here, 4, 2, and x. All right, get rid of my 4's, our 2's, and then the x. We are left with 2x plus 4x equal to 8. Bring these guys together to give me 6x equals 8. Then we're going to divide. 8 divided by 6 is going to equal 1.33. So if both valves are open, it's going to take 1.33 hours. Okay, so together, it would take 1.33 hours to drain the vat. All right, last word problem. JT can blow the leaves off the sidewalks around the Capitol building in 2 hours using a gasoline-powered blower. Kimberly can do the same job in 8 hours using a broom. How long would it take them working together? All right, well, let's see here. JT with his gasoline-powered blower is going to do the one job in 2 hours. Kimberly and her broom does the one job in 8 hours. We do not know how long it's going to take them to work together. So it's set up, multiply by 2, 8, and x. All right, we do this so we can cancel out our denominators. And then we combine what is left. So over here we have 8x. In the middle, we have 2 times x. And we are equal to 2 times 8, which is 16. All right, this gives me 10x equals 16. We're going to divide by 10. So 16 divided by 10 is going to be 1.6. So if they worked together, it would take 1.6 hours to clear out the sidewalks. All right, so now we're going to solve rational equations. This is the last piece. So with solving, our goal here is to get rid of our denominators, okay? So in order to do this, I need to know what the common denominator is. So that way I can multiply it across and get rid of all the pieces that are underneath. So with 26, I only have one denominator here, and it's x. So, but I can't just multiply this side by x. That would unbalance the equation. I have to multiply everything by x. So here it does serve its purpose. It gets rid of my denominator, but that means I have to multiply it on this side. So we're going to get 5x plus x squared is equal to 24. All right, I see an x squared. I'm going to have to factor it. So I'm going to bring everything to the one side. So that is going to give me, I'm going to go over here, x squared plus 5x. And then I have to subtract 24 over. So minus 24. This factors to give me x plus 8, x minus 3. So x equals negative 8, and x equals positive 3. Now before I circle, I need to make sure that plugging these into my denominator will not create an excluded value, meaning this would make it 0. So negative 8 and 3, we're good to go. The only thing x is not allowed to equal in this problem is 0, and I did not get that. So x equals negative 8 and positive 3. All right. 27. I have a little bit more happening here. I'm going to factor out this denominator. So multiply to give me 3, adds to give me 4. That's going to be x plus 3 and x plus 1. Right? So I see that they all have an x plus 3, but this guy also has an x plus 1. So if I need all of these factors to also be in my numerator, so the factors that I am dealing with, my common denominator, they all have an x plus 3, and we also have an x plus 1. You have to represent all the factors. Okay? This means, and I'll go ahead and do this also, excluded values here, x cannot equal negative 3 or negative, not negative 4, negative 1. Okay? So, x plus 3 and x plus 1 is what we're going to multiply to each and every numerator. Okay, they are all, I can't just do it to the 1, I have to do it to everything. X plus 3, x plus 1, and then x plus 3, x plus 1. All right, so here it gets rid of the entire denominator, which is what needs to happen. My middle piece, my denominator still cancels, right? X plus 3, x plus 3, but x plus 1 is going to stay. The end, same thing happens. X plus 3 goes away, but I have the x plus 1. Right? I also just saw this is a minus problem, so I need to distribute that. There we go. Alright, so now I need to multiply what is left in our numerator. Okay? This numerator, since this piece got canceled with our denominator, is still just x minus 4. Okay? Here, I have x minus 3 times x plus 1. And then on the other side, minus 1 times x plus 1. All right, let's simplify. This side is going to stay the same right now. We're going to keep it x minus 4. We have to FOIL this out. This is going to give me x squared, right? And then 1 minus 3 gives me negative 2, minus 3. And then minus x minus 1. Okay, a lot's happening. Let's bring all of this over here. So I'm going to subtract x and add 4. Now let's combine like terms. All right, I only see one x squared. So here we go, x squared. Negative 2 minus x is negative 3. Minus x is negative 4. So minus 4x. All right. And then I see negative 3 minus 1 is negative 4. Oh, plus 4, so that's 0. Right, so that's all we have. So all of that turned into just x squared minus 4x. Right, I can factor an x out. So that gives me x times x minus 4. So here I have x equals 0 and x equals positive 4. Both of those are good because neither one of them are negative 3 or negative 1. So those are your answers for number 27. That was a lot. That was a good problem. I like it. All right. Let's do that again with 28. All right, so, I'm going to go ahead and distribute this negative to this 4 before I do anything else. And then I'm going to factor our denominators. They're both the same thing. So multiply to give me positive 6 and add to give me a negative 5. That is going to be negative 3 and negative 2. Okay. So now let's focus on our denominator here. They all have an x minus 2. Then these pieces also have an x minus 3. So our common denominator is going to be x minus 3 and x minus 2. That's what we're gonna multiply across the tops because we need each piece represented in the numerator so I can have a common factor to cancel. Okay? In the end, if I get x equals to 3 or 2, then that's going to be extraneous because I can't equal those two. It would make them 0. All right, everything gets x minus 3 and x minus 2 here and here. X minus 3, x minus 2. All right, so now we can cancel out common factors. Here it's going to be both of them. In the middle, it's just x minus 2. On the end, it will be both of them. So what do I have left? Well, right here, I just have a 1. In the middle, I have negative 4 times x minus 3. And then on the other side, it's just a 2. All right, let's distribute and combine like terms. Here we go. 1 minus 4x plus 12 will give me 2. I'm going to subtract the 12 and subtract the 1 to the other side. So 2 minus 12 is negative 10, minus 1 is negative 11. So I have negative 4x equals negative 11. Divide, we get x equals 11 over 4, which is not 3 or 2, so we are good to go. All right, 29. Okay, I see 2 denominators. I also see a minus sign. Let's go ahead and get rid of that. There we go. Okay, so technically this has a denominator of 1. So what do I need to cancel out an x and a 2x? Well, I'm going to need the x, right? In my numerators, I'm also going to need a 2. So our common denominator here is 2x. That means that our excluded value, x is not allowed to equal 0. Okay, so I need 2x in my numerators. So here we go, 2x, 2x, and 2x. In my first one, just the x's will cancel. In the middle, actually nothing cancels. In the end, everything does. So right here, I have 2 times 2, which is 4. In the middle, I have 2 times 2x, which is 4x. And then we're left with the minus 1. All right, I'm going to add that over. So 5 equals 4x. Divide by 4. We get 5 over 4 equals x. All right. Oh, I didn't show you any of that. Here we go. All right, guys, last one. We can do it. Number 30. Again, I see a minus sign. Let's go ahead and get that over. Factor our denominators. These are both differences squared. So we have x plus 3 and x minus 3. So what's our common denominator? Well, they all have an x plus 3. I'm also going to have to include x minus 3, so that way I can cancel it out. If I don't bring it to the top, I can't cancel. So everything gets an x plus 3 and an x minus 3. This means that our excluded values for this one are going to be negative 3 and positive 3. So hopefully I don't get one of those. Otherwise I'm going to have to take it away. All right, first one, everything cancels out, so I just have an x plus 2. In the middle, again, everything cancels, so it's just a minus 1. On the other side, just the x plus 3 cancels, so I have 2 times x minus 3. All right, I'm going to distribute. So that gives me, let's see, 2 minus 1 is just 1. So x plus 1 equals 2x minus 6. I'm going to subtract this x over. So that's going to give me x on this side. I'm going to add 6 over here. And that just gives me 7. Okay. Remember, x was not allowed to equal 3 or negative 3. And that didn't happen. So we're good to go. All right, so I know it's a long video, a lot of work, but you're going to do awesome on your tests, and then you're going to have a fabulous Thanksgiving break, and you're going to come back, and we're going to get ready for performance final. So enjoy your break, study for your test, and you'll do great.